Okay, so today we're going to cover section 8.6, which is solving exponential and logarithmic equations. Now, what you need to really make sure you understand is that a logarithm is a power that a fixed number, which is the base, must be raised to in order to get some other number. So if you truly understand what a logarithm means, then transferring back and forth between log and exponentials is much easier. So a logarithm is a power. A log is means equal. A log is a power that a fixed number must be raised to in order to get some other number. So what the log equals is the exponent for your base. So this to this power equals whatever this is, equals some number. So the base to the power equals some number. And so therefore, if you have the equation of the log, you can write the equation of the exponential. You can convert back and forth between the two. So the first set of problems we're going to do is we're going to solve exponential equations where the variable is up here in the exponent. Alright, so we have 2 to the x equals 7. Well, in order to solve for this variable up here, we need to be able to release it from this base. And we learned before that if we take the log of both sides, it will allow us to be able to release this exponent. So that's what we'll do. We'll do the log of 2 to the x power, but what you do to one side, you have to do the other, equals log of 7. That allows us to be able to take this x and bring it out. So x times log of 2 equals log of 7. Now all we need to do is we need to get our logs together. So we divide both sides by log of 2. It cancels from the left. And now all we need to do is calculate log of 7 divided by log of 2. And when we calculate that, that equals, let's round to 2 places after the decimal, 2.81. So let's look at number 2. First of all, you should always ask yourself, what am I solving for? I'm solving for x. What does it belong to? It belongs to this 10. So that is what I need to get by itself. So I need to get rid of the plus 5. So in order to get rid of the plus 5, I'm going to subtract 5 from both sides. So we have 10 to the x equals 55. Now you're at a point where you have to ask yourself, how do I solve for this power? Well, the log is equal to that power, so we're going to take the log of both sides. The log of 10 to the x equals the log of 55. Doing that lets us release the power. So that's x times log of 10 equals log of 55. Again, just like problem number 1, we're going to get rid of this by dividing both sides by log of 10. And then we're going to calculate this. We're not going to write it as one log because we can't put that in our calculator. So we're going to calculate this, log of 55 divided by log of 10. And when you round it to 2 places after the decimal, you get 1.74. So taking the log of both sides allows us to release that power so we can solve for it. Let's look at number 3. Okay, so here, ask yourself, what am I solving for? I'm solving for x. What does it belong to? Well, it belongs to the 2, but that ultimately belongs to the e. So e to the 2x is what I need to get by itself. Well, 4 is multiplied to e to the 2x. So in order to get rid of it, I need to divide. So now I have e to the 2x equals 5/4. I'm going to go ahead and leave that as 5/4. I'm not going to calculate it because I'm going to wait and calculate it at the end. Now, I'm solving for x. It is in this power. The only way to release that power or to separate it from its base is to take the log of both sides. So the log of e to the 2x equals the log of 5/4. Doing that, because of our log property, lets us take that power out. So 2x times log of e equals log of 5/4. Okay, just like the other problem, we have to get this by itself, so we have to get our logs together. So we're going to divide both sides by log of e. So that gives me 2x equals. Now, I am going to write this as one log because what this is log base e. Now, you don't have to write it as one log, but what I want you to recognize is anytime you have log base e, that is the same thing as ln. So log base e is the same thing as ln. So that's ln of 5/4. This is ln of 5/4. To get rid of the 2, we just have to divide both sides by 2, and then you calculate ln of 5/4 divided by 2. Now, you didn't have to put ln of 5/4. You could have left it like this, calculated this, and then divided it by 2. You would still get the same answer. And so when we do that, we get x equals 0.11. Problem number 4. Again, what are we solving for? X. What does it belong to? E. So that's what we have to get by itself. First thing we need to do is get rid of this plus 8. So we subtract 8 from both sides. So then you're left with negative 12 e to the negative x equals negative 1. Again, this is what I need by itself, so I need to get rid of this negative 12. That's multiplied, so I need to divide both sides by negative 12. So you have e to the negative x equals 1/12. Just go ahead and leave that alone. Now, we're solving for our power. What we're solving for is in our power, and so we're going to log both sides. Log of e to the negative x equals log of 1/12. The power is now able to be released, so negative x times log of e equals log of 1/12. All right. Now we divide both sides by log of e. So you have negative x equals. Now, again, this is log base e of 1/12. That is the same thing as ln of 1/12. Log base e of 1/12 is the same thing as ln. That's the natural log. So all I have left to do now is divide both sides by negative 1 and then calculate ln of 1/12 divided by negative 1, and you get 2.48. Let's look at the last one, number 5. Now, I'm going to show you 2 separate ways to work this. Method 1. Is what you already know how to do. Method 1 is we have 10 to the x minus 3, and you can go ahead and put that in parentheses, equals 100 to the 4x minus 5. Now, in order to release these powers, we have to log. We have to use the log. Okay, the log will allow us to move the exponent out in front, but since we're logging both sides, it's going to take care of both of them at the same time. So log of 10 to the x minus 3 equals log of 100 to the 4x minus 5. Now we take our exponents, x minus 3, put it out in front, and 4x minus 5, put it out in front. I'm going to erase this for now so that I have more room. We'll come back to method number 2 in just a second. Alright, so take the x minus 3, put it out in front. X minus 3 times log of 10 equals, then bring the 4x minus 5 out in front. 4x minus 5 times log of 100. Okay? Now, we have log over here and log over here. We need to get them together. And so, if I divide this by log of 10, that cancels. But I have to divide the other side by log of 10 as well. So now I have my logs together on the right. I want my x's together on the left. So I need to get rid of this 4x minus 5. So I'm going to divide by 4x minus 5 on both sides. So let me rewrite what I have now. Now I have x minus 3 divided by 4x minus 5 equals log of 100 divided by log of 10. Calculate this. If you calculate this, log of 100 divided by log of 10, you get 2. Well, if I put that over 1, now I just have a proportion. How do we solve a proportion? We cross multiply. So x minus 3 times 1 is x minus 3 equals 2 times 4x minus 5. So we go ahead and distribute. X minus 3 equals 8x minus 10. Bring the x over there, we subtract x. Bring the negative 10 over there, we add 10. So 7 equals 7x. Divide both sides by 7 and x equals 1. Now, that was quite a lengthy process. That was quite a lengthy process. There is a faster way. So, if we have, so here's method 2. Do you agree that if I have two things with the same base, then the exponents have to be the same if they're equal? For example, if I have 3 to the x power equals 3 to the 5th power. If these are the same and they're equal, then my exponents have to be the same. So if these are the same, then the exponents have to be the same, so x has to equal 5, right? Well, here our bases are not the same. However, we can make them be the same. This has a base of 10. I can take 100 and change it to 10 to the something power. So 10 to what power equals 100? Well, 10 to the 2nd power. So I have 10 to the x minus 3 equals, now I'm going to take 100 and I'm going to change it to 10 squared. However, we don't forget about this. This is still there. That is still 4x minus 5. It's still in my exponent. All I did was replace 100 with 10 squared. Now my bases are the same, so that means the exponents have to also be the same. So that means that x minus 3 has to equal 2 times 4x minus 5. Well, let's look at our two methods. I went from the first step, the original problem, 1 step, 2 steps to get to this equation. Original problem, 1, 2, 3, 4, 5 steps to get to here. This is the same thing as this, but I got there a lot faster by forcing my bases to be the same. And so once you have this equation written, you go ahead and solve it like you normally would, just like you did the other one. Then you would distribute the 2, so x minus 3 equals 8x minus 10. Subtract x to cancel this, add 10 to cancel that. Okay, so you end up getting there a lot faster. That works anytime you can make the bases be the same. For example, if you had 9 to the 2x equals 27 to the x minus 4. I can force both of these to have the same base. Now remember, I'm changing these to the something power. Okay? I'm going to put parentheses around these to represent the original exponent. So 9 and 27, I can both write them as 3 to the something power. 9 is 3 to the second power, and then I have that 2x. 27 is 3 to the third power, because 3 times 3 times 3 is 27. But I still have the x minus 4. So now that the bases are the same, I can say that the exponents must also be equal. So then it would be 2 times 2x equals 3 times x minus 4. And then you would just continue to solve for x as you normally would any equation. So it would be 4x equals 3x minus 12. Subtract 3x, and x equals negative 12. So if you can make the bases be the same, it's a much faster process. Let's move on to log equations. Now, remember what a logarithm is. A logarithm is a power that a fixed number must be raised to in order to get some number. So we're solving for 3x. We're solving for x here. It belongs to this log. It belongs to that log. Now remember, if there's no base present, you are to assume it's base 10. So that means I need to get rid of this 2. So I'm going to divide both sides by 2. So I get log base 10 of 3x equals 2. Once you have a regular log equal to some number, what we're going to do is we're going to write the equivalent equation. We're going to write the equation. Remember that a log is equal to a power that a fixed number is raised to in order to get some number. So you say 10 to the second power equals 3x. So once you have your log equal to a number, you write the equation. Write the equation that you need to solve. And so 10 squared equals 3x. Divide both sides by 3. So x equals 10 squared divided by 3, which is 33.33. So let's do number 2. Again, what am I solving for? X. It belongs to this log. So that means I need to get rid of this 1/2. Well, how do you get rid of 1/2? Well, you either divide by 1/2, which is the same thing as multiplying by 2. So we have log base 2 of 16x to the 5th equals 16. Now we're at a position where we can write our equation. because there's nothing else you can do. You can't calculate the log of 16x to the 5th. You can't do that. And so let's write our equation. So 2 to this power, remember the log equals the power. 2 to this power equals 16x to the 5th. 2 to the 16th power equals 16x to the 5th. Now, I'm going to work smarter, not harder. Meaning, I'm not going to start calculating as I go. I'm going to wait until the very end to calculate. I need to solve for x, which means the next natural step would be to divide both sides by 16. So I have x to the 5th equals 2 to the 16th divided by 16. The next thing I do to solve for x is I take the 5th root of both sides. And I calculate all of this at one time. That way, I'm not doing more work. I'm only calculating at one time. You never want, you can calculate as you go as long as you don't have to round off. You never want to round off as you go because your answer is not going to be accurate. And so this will give you x equals 5.28. All right, let's do a couple more. Again, what am I solving for? I'm solving for x. What does it belong to? ln. Remember, that's just the natural log. That's log base e. So I need to get rid of the 5 and the 2. You always get rid of what's added or subtracted first. So we're going to subtract 5 from both sides. So 2 ln x equals -1. Now we need to get rid of the 2. So we divide both sides by 2. So ln of x equals -1/2. Now we're ready to write our equation. Remember that ln has a base of e. So that's e to the -1/2 equals x. Well, e is just a number. Just calculate that. So x equals 0.61. Let's look at number 4. What's different about number 4 is I have 2 logs. Well, you can't write the equation until it's only 1. In yesterday's lesson, we learned how to condense these and write these as 1 log. Since they're separated by subtraction, we can write them as 1 log using division. Now we're in a position, remember, that's base e. Now we can write our equation. E to the 1 power equals x minus 4 divided by 2. Now remember that e to the 1 power is just the same thing as e, right? So I don't need to put the 1 power. So let me go ahead and start solving. So the first thing I need to do to get x by itself is I need to multiply both sides by 2. So I have 2e equals x minus 4. The last thing I need to do is add 4 to both sides. So I have 2e plus 4 equals x. Calculate that. Remember, e is a number. So 2 times e plus 4 is 9.44. Okay, we have 2 more to do like this. Let's look at number 5. Let's look at number 5. All right. Now, before I do that, remember when we talked about if you had an exponential on the left and an exponential on the right, if the bases were the same, then their exponents would be the same. Well, the same thing works for logs. So think about it. If I had log base 2 of x equals log base 2 of 7, Well, if this has to be exactly equal to this, then x has to equal 7. If these are the same, then these also have to be the same. That's just logic, okay? So we're going to use that logic to work our next problem. Okay. So, first thing we need to do is we need to put our exponents back in place. So that is log base 3 of x equals log base 3 of 4 to the third power minus log base 3 of 2. Okay? I need to condense this right-hand side so that I have one log on the left and one log on the right. And then we could set x equal to whatever's in parentheses on the right-hand side. So we have log base 3 of x equals. Now, you don't need to calculate this, or you can. 4 to the third power is 64. But you don't need to. Log base 3, since they're subtracted, we're going to take this and divide it by this. Log base 3 of 4 to the third power divided by 2. So we have log base 3 of x equals log base 3 of, well, 4 to the third power divided by 2 is 32. Therefore, since the bases are the same, this has to be the same as this. So x equals 32. All right, now let's look at number 6. Okay, same thing. I have log base 3 of y on the left. I need a single log on the right so that I know what y is equal to. So what I need to do is I need to condense this. So first thing I'm going to do is put my exponent back. So that's 2 to the third power. And then I'm going to put my 1/5 back. So it's 32 to the 1/5 power. Okay? So I have log base 3 of y equals log base 3 of, well, 2 to the third power is 8, plus log base 3 of 32 to the 1/5 power is 2. So now I'm going to write that up. The right hand side is 1 log. So log base 3 of y equals log base 3 of 8 times 2. So log base 3 of y equals log base 3 of 16. Therefore, y equals 16. Last thing we're going to do is we're going to look at an interest problem. It says you deposit $500 into an account that pays 6.75% interest, compounded continuously. So is that the short formula or the long formula? Well, that's the short one. That's y equals p times e to the RT. How long will it take the money to double? How long will it take? So we are solving for t. So we have y, or a, equals p times e to the RT. And we're solving for t. So that means they had to have given us everything else. You deposit $500. So that's what you start with. 500 times e to the, it pays 6.75% interest. So R equals 0.0675 because you have to write it as a decimal. We don't know the time. How long will it take the money to double? So what's the after amount? Well, if we started with 500 and it doubles, we have to end with 1,000. So here's our equation that we need to solve. What we're looking for is up in this power. Well, thank God we know how to solve this now. We just learned how to do this in the part 1 of this lesson. We're solving for t. It belongs to e. So that means I need to get rid of 500. So I divide both sides by 500. So we have 2 equals e to 0.0675 t. Well, how do you release the power? You use the log. So log of 2 equals log of e to the 0.0675 t. Bring your exponent out in front. Log of 2 equals 0.0675 t times log of e. You're solving for this. Get rid of the log so it goes with the other one. So you get your logs together. .0675t equals, if I write this as one log, that's ln, because it's log base e of 2, so that's ln of 2. And then we just have to divide both sides by 0.0675. So t equals, if you divide this, you get approximately 10 years. So it takes 10 years for $500 to turn into $1,000, compounded continuously at an interest rate of 6.75%.